Hope you can see my screen. Thank you for joining me today. My name is Nishantan, and I am a senior software engineer working on EmployFT project. Uh, Today, we are going to explore an essential topic for mostly for developers, like caching strategies that help make APIs perform faster and scale better. So, whether you are building small services or large distributed system, understanding caching can significantly improve user experience and reduce infrastructure costs. So let's dive into how we can leverage caching effectively to build high performance scalable API. Before we move into details, here's the quick overview of what we will cover today. We'll start with basics, understanding what caching is and why it matters, especially in the context of APIs. Then we'll explore key concepts like cache hits and misses, followed by common use cases where caching can make big difference. We'll also discuss best practices to keep your caching effective and efficient, and a small demonstration to show how caching can enhance the performance of an API, and some challenges in caching, also real world caching scenarios, and also summary of caching layers, and some key takeaways from cachings. Okay, let's start with the basics. So, what is caching really is? In simple term, caching is about storing frequently used data in a place where it can be accessed quickly. So the next time you need it, you don't have to do all the hard work again and again. This is important because some things take times, like running complex calculation or asking a database for information. This caching helps us to avoid doing that again and again. Caching can take place in various places. For example, your web browser, it may save images and scripts, so they don't need to be downloaded every time when you visit a website. Sometimes network devices or proxies also store copies of data. And on the server side, APIs often keep cache data ready to deliver quickly. Um, in the end, caching can make system faster and more efficient, like less waiting time, less load, and better experience for users. So by saving the right data in the right place, we can speed things up a lot. So now, why is caching so important, especially when we talk about APIs? Uh, APIs usually get their data from databases, or sometimes you may like an external service, for example, and any other example service. So both of these can be slow or take up a lot of resources. So every time an API makes a call to fetch data, it uses time and computing power. So if a lot of users are doing this at the same time, it can slow everything down. So caching helps by reducing these repeated calls. Instead of asking the database or service every time, the API can quickly grab the data from the cache. So this lowers the delay or latency of user experience. So that means faster response means we got happier users who don't have to wait. It also means your system can handle many more users at once without needing to add any expensive hardware. Uh, Sorry. And also, if you are using a third-party APIs, that like sometimes the external APIs that charge based on how many calls you make. So for these things, caching can save your money by cutting down those calls. So caching, it's not just about speed; it's about making your whole system more efficient and effective, cost effective. Uh, let's talk about two important terms you will hear when discussing caching. That is cache hit and cache miss. So a cache hit happens when the data you need is already stored in the cache. This means the system can skip the heavy work of fetching or calculating the data again and just deliver it immediately. This actually leads to much faster response. If you see on the other hand, the cache miss means the data isn't in the cache yet. So the system has to go all the way to the original source like the database or external service. To get it after fetching it, the system usually store the data in the cache for the next time. So the actual goal here is to have high rate of cache hits because that directly improve the API performance. For example, imagine an API that return product details. If the API fetches from the database every time, it slower and uses more resources. But if it gives that data from cache most of the time, responses are much quicker and database load is reduced. Now that we know what caching is and how hits and misses work, so let's look at some real situation where caching really used in API side. So first is frequently accessed read-only data. Things like product catalog or application configuration settings. These actually don't change very often. So caching them can save a lot of repeated database queries. The second one is computation heavy results, such as generating analytics summaries or detailed reports. So if producing these results required significant processing, it's far more efficient to cache the output and reuse it instead of recalculate it again and again each time. Third one is response from the third party API. So this is important. Like if the API you are calling is slow and charges per request, so caching its response can not only improve the speed but also can reduce the cost. The fourth one is user profile data the profile data that doesn't change often. So like for example, the basic details like name, email, and settings, those can be cached for some time without much risk of becoming outdated. So because those details not much often changed. And finally, pre-rendered templates or partial HTML for front-end rendering. By caching these, you can reduce the amount of server-side work need for each request, which also improves the responsiveness for users. Um, Actually, caching can be done in several ways. The right choice depends on your application needs. So first one is in-memory caching. This stored data directly in the application's memory. So it's very fast because there is no disk or network involved. But the downside is that it's limited by the memory of the single machine. The other way is file-based caching. So it means saving data to the disk. This allows the cache data to remain available even if the application is restarted, which is helpful, but accessing data from disk is slower when comparing to getting from the memory. Then there is distributed caching, where a shared cache store is used across multiple servers, like with popular tool like Redis or Memcache. This lets your entire system to access the cache data, so making it easier to scale across many machines. And finally, HTTP response caching. This actually happens at the browser or proxy level using HTTP headers like cache control or ETEC. So this way, the response can be reused without hitting your server at all, which saves actually bandwidth and your server processing. So in many real world systems, you will find this combination of these cache types working together. So if you use it correctly, you can deliver the best performance. Uh, In-memory caching, we'll look into more into in-memory caching. So in-memory caching is one of the fastest ways to cache data because it store information directly in the RAM of your application. Since the data is in memory, so retrieval is very quick. So mostly often just like a nanosecond or microseconds. So it's perfect when you need low latency access. It's especially useful for small, frequently accessed data sets, things like, for example, configuration values or small lookup tables or pre-computed results that what your application uses all the time. And of course, there are limitations. So the most important one is that all cache data is lost if the application gets restarted because it lives only in the memory. Also, you are limited by the available RAM. So too much caching here can cause memory pressure and even slow down the application. Some common tools for in-memory caching include like in .NET we use memory cache, and for Java there is Guava cache. So mostly programming languages have similar built-in or third-party libraries that making that usually it's easy to implement as they're using libraries for each programming languages. So if you consider in short of this memory caching, it's extremely fast and perfect for small and frequently accessed data set, but not suitable for very long term or very large scale storage. We'll move on to distributed caching. So this approach stored cache data in centralized cache server that multiple application instance can access. So this is especially useful like in modern load balance environments where you can have many servers handling requests. So distributed caching can help the data consistent across these servers. So they all share the same cache. So unlike in memory caching, distributed cache often support persistent and can handle much larger data sets. So making them suitable for high scale applications. Um, there are some popular distributed caching systems are Redis and memory cache. So both are widely used. Mostly you have heard of Redis. Here you can find some difference between. So mostly they use Redis for those distributed caching. Some the main benefits of distributed caching are scalability. It will letting you to add more servers easily, and another advantage is fault tolerance. So because it can keep working even if the server is failed, and also the ability to share cache data across different parts of your system or even between different applications. So as a summary, distributed caching is a powerful way to scale caching beyond single machine and is a key component in many large-scale API architectures. So now let's discuss cache invalidation. This is actually often considered one of the most challenging aspects of caching. So actually, why does it matter? Because if your cache hold on to old or outdated data, you might end up serving incorrect information to users, which can break functionality or cause confusion. So there are a few common strategies we use to handle invalidation. First one is there is time-based expiration, also known as TTL. That means time to live. This means cache data is automatically removed after certain time, like 5 minutes or an hour, to keep the information up to date and prevent it from becoming stale. Second one is manual invalidation. So it involves explicitly removing or updating the cache items when you know the underlying data has changed. For example, if a product price changes, you might clear its cache details right away. And finally, there is event-based invalidation. So where cache refreshes are triggered by specific event or changes in the system. So this could be through messages, queues, or signal or hooks that actually have to tell your cache to update when it's necessary. So getting cache invalidation right is critical. So to maintaining both performance and data accuracy in your system. Finally, here are some caching best practices. First is cache selectively. So not everything needs to be cached. So focus on the data that's read frequently and is expensive to compute or fetch. Second one is set proper expiration time. So this is about finding the spot between keeping the data fresh and maximizing the performance. That means if it is too short and you lose the benefit of caching, and if it is too long, you risk the serving stale data. Third one is implement graceful fallbacks. So if there is a cache miss, meaning the data isn't found in the cache, your system should be able to fetch it from the original source without crashing or slowing down the application. Fourth one is monitor cache hit and miss ratios. These metrics will tell you whether your cache is actually effective and help you to fine tune your strategy. And finally, avoid over caching. So more caching isn't always better. So it can waste your memory and increase the chances of stale data issues. Maybe following these practices will help you to get the most out of your caching strategies without introducing new problems. So for the demonstration, my goal is to show how caching can impact API response times by avoiding repeated work. So we'll focus on file-based caching of API response where the cache data is saved to a local disk. This means that even if the application is restarted, the cache data remains available for faster retrieval. Actually, file-based caching is slower than in-memory caching since it's reading and writing to disk, so it takes more time. But it's simpler to implement and useful when the application restart or some other requirements are needed. So it's especially good for caching medium-sized data sets or results of expensive operation like database query or heavy computation that doesn't often change. Uh, this is just a simple API call example designed to clearly show how caching can improve the performance in practice. So we'll move to the demonstration. So what I did was I just created two APIs. One will directly return the data from the database, and another one will check whether the caching file is exist, or if it is exist, it will be considered as a cache hit and it will return it from the cache file. If it is not there, it will considered as cache miss and it will retrieve the data from the database and write it to the cache file, then return the data. So I will move to the demonstration. So here at both at same time, there's no local API call and the caching API call is requesting. You can see this one, the original API data is load faster than considering the cache data API call because this is the first time, so there is no cache file exist. So the cache miss is happening. So the data is retrieved from the database and it's writing to the cache file, then returning to front end. So here actually it returned around 100,000 records. So normal API took around 4 seconds and this is took around 10 seconds. So if I refresh the application and test the performance again, now it will get it from the cache file and it will be much faster. It's less than 1 second now. And the existing API, it will take the same time, like 5 seconds or 4 seconds. So this is actually to show the how the performance can be enhanced through caching the necessary and useful information through APIs to enhance the performance. So this is just a small demonstration to show that. We'll move back to the presentation. So now that we have seen caching work, so let's look at some challenges we might run into when using caching in real system. So first one is the data staleness. So cache data can become outdated if it's not refreshed. So for example, imagine let's say a product price changes in a database, but the user keeps seeing the old price from the cache. That can be lead to confusion or even financial loss. The second one is invalidation complexity. So it's tricky to ensure all relevant caches are cleared after an update. Like think of an e-commerce site where you update the stock quantities, but the cache of the product page still shows as in stock. So that can be result in overselling. Uh, Third one is memory and storage limits. The caches can grow large if not managed properly. So for example, in Redis, for instance, unbound caching of large objects can cause to eviction of important items. So even crash the service if memory fills up. Um, Finally, concurrency issues like multiple writers to the cache can cause race condition. It means like if two servers update the same cache key at the almost the same time, one might overwrite the other update. So it will cause inconsistent results. Uh, Here, a special case here is cache stampede. Like when many requests hit an expired cache key simultaneously and try to recompute it at once. So this can overload the backend. Uh, so you can prevent it with like, for example, strategies like lock and refresh or randomizing the expiration time, or you serve the old value while refreshing in the background. So although caching can greatly boost performance, so it's important to carefully manage and update and also monitor it to prevent these common problems. Let's look at some real world examples where caching plays a critical role. First one is e-commerce. So online stores cache product details like names, price, and images to avoid hitting the database for every product view. They also cache inventory status, so the in-stock label load instantly. So this not only speeds up shopping experience, but also reduces server strain during big sales. So, for example, discounts a day or some example as of Black Friday. So those times also it will reduce the server strain. Second one is social media. Platform like Facebook and X cache user feeds, so you don't have to rebuild them from the scratch every time you refresh it. So the trending topics also cached and updated periodically. So millions of users see the same result quickly without generating huge database load. Third one is news portals. So news websites actually cache headlines and top stories, refreshing them every few minutes. This ensure visitors always see the latest news almost instantly, even during the high traffic breaking news events. Lastly, API gateways. So gateways often cache authentication tokens and rate limits checked to avoid repeated calls to authenticated server. So this can drastically cut latency for services that handle millions of requests per second. So these scenarios show how caching isn't just performance trick. So it's like a backbone strategy for keeping system responsive and scalable in the real world. So let's quickly summarize the main layers where caching can happen. So first one is client-side caching. This happened right in the user's browser. So things like browser cache, service workers or local storage store assets and data locally. That means page load faster because they don't have to fetch everything from the server every time. Second one is edge or proxy caching. So this is where CDNs like Cloudflare comes in. They store copies of your content in a data center across the globe. So users get it from the nearest location. So it reduces the latency. So the third one is server-side caching. This is uh, this is caching within your application or backend. So it could be in memory caching, or like Redis or meme cache, or even an in-process cache for quick looks up. This layer actually helps to reduce the expensive database or API calls. And finally, persistent caching. So here the cache stored in a file system or special database table for long-term use. It actually slower than memory caching, but it survives like application is restarting and also can handle large data sets. So let's wrap up this up with the key points to remember about caching. So first one is performance, scalability, and cost. So caching isn't just about speed; it also reduces load on your servers and saves money by avoiding unnecessary processing and data transfer. Um, Second, right cache for the right jobs. That means always choose your caching type based on how your data is accessed and your overall system design. And also, you have to like monitor it regularly. Like cache strategies are like not set it and to forget about it. So you should have regularly for monitoring to ensure the cache is fresh, accurate, and actually helpful. And lastly, caching plus profiling. So caching works best when guided by real profiling data. That means finding the bottlenecks in the caching, then cache smartly. Um, yeah, that's all for the this session. So thank you all for your time and attention today. So caching is a fundamental technique that when you done it right, it can dramatically improve the speed and scalability, also the efficiency of your APIs. So I hope this session gave you some basic useful insights and practical ideas to take back to your own project. So if you have any questions or anything, you can ask. If nothing, we can wind up the session. Again, once again, thank you everyone for joining that today.
Okay, thank you, Nishanthan, for your valuable session.
Yep.
Thank you, Nishan.
Thank you,
Thank you,
Nishant.
Nishanthan.
Thank you, Nishant.
Thank you, Nishan.
Yeah,
Thank you.
thank you.